Okay. Welcome to the 10th lecture video for the Math 22 series, M1 109, in preparation for the first LE. And ngayon, magdi-discuss tayo tungkol sa Absolute Convergence and Tests for Absolute Convergence. So what is Absolute Convergence? Absolute Convergence is actually part of two types of convergence. So a series, A sub n, is only said to be absolutely convergent if yung absolute value na A sub n is convergent. Conditionally convergent if yung A sub n is convergent pero yung absolute value na A sub n na series is divergent. So there's a theorem relating dito sa absolute convergence. If a series A sub n is convergent, yung absolute value, then yung series na A sub n lang is also convergent. Likewise, if the series na A sub n is divergent, then yung absolute value ng series na A sub n is also divergent. Okay, so what test do we use for this part? So may dalawa tayo. These are the main tests to be used dito sa absolute convergence. And you can also use yung mga tests na ginawa natin during the previous lectures. So here are the two main tests, yung ratio test at saka root test. So let A sub n be a series where A sub n is not equal to 0. The ratio test is usually used for series with factorials and exponents. Nasa form siya na limit as n approaches positive infinity of the ratio ng A sub n plus 1 and A sub n. And this is equal to limit L. On the other hand, the root test is usually used if A sub n consists of only powers of n. It is in the form limit as n approaches positive infinity of the absolute value of A sub n raised to 1 over n, which is also equal to a limit L. So there are three possible scenarios for both tests, and palaging may kinalaman ito sa limit L. So first, if the limit is less than 1, then the series is absolutely convergent. 2, if the limit is greater than 1 or positive infinity, yung katupas niya, then the series is divergent. 3, if the limit L equals 1, then both tests are inconclusive. So let's try some problems relating to absolute convergence. So first problem, determine if the series below is convergent or divergent. So summation of from n equals 1 to positive infinity. Now, absolute value, now 3 sine n all over 4n squared of n plus n. So you may pause kung gusto nyo isolve, then we'll show the solution later. Okay, so here's the solution. Notice na yung absolute values ng 3 sine n all over 4 square n squared of n plus n is less than or equal to 3 sine n na non-under absolute value. And notice na natanggal ang absolute value itong 4n squared of n plus n. Kasi itong 4n squared of n plus n are positive since n is a positive integer palagi. So this one is less than or equal to 3 over same denominator kasi absolute value of sine n will always be less than or equal to 1. This is also less than 3 all over 4n squared of n kasi notice na both has yung plus n is makes this greater than this, and pag ni-reciprocal since nasa denominator, this is less than. So kaya ganyan. Then we now transpose n squared of n into one variable n raised to 3. So let's next. Notice na itong 3 over 4n raised to 3 half is a t series with p equals 3 half greater than 1. So because of this, itong 1 over n raised to 3 half is convergent, implying na yung same series multiplied by 3/4 is also convergent. So by the comparison test, dahil yung original series ay less than a convergent series na 3 over 4 n raised to 3 half, then yung series na to is convergent. Therefore, absolutely convergent siya by the comparison test. Okay, let's proceed with problem number 2. Determine if the series below is convergent or divergent. So we have summation n equals 1 to positive infinity, negative 1 raised to n minus 1 all over 3. So pause ulit kung gusto nyo isolve, then we'll show the solution later. Okay, so here's the solution. So, test muna natin yung absolute convergence. Notice na pag in absolute value ito, magiging 1 over 3n kasi this is always equal to 1 no matter what kapag in absolute value. And yung 3n ay positive kasi n is a positive integer. So, pag in-isolate natin itong 1/3 sa labas, matitira 1 over n. And notice na itong 1 over n na series is actually a harmonic series. And we know that this diverges. So, yung series na ito is not absolutely convergent. So now let's test the second part, which is yung conditionally convergent. To test this, let's use the alternating series test. Kasi notice na yung -1 is alternating kapag yung exponent ay n minus 1. So let Bn equals the absolute value ng a sub n, which is 1 over 3 sub n, which is positive for any n. Notice na when Bn plus 1, and n plus 1 is equal to 1 over 3n plus 3. And this 1 over 3n plus 3 is actually less than 1 over 3n. Kasi 3n plus 3 is greater than 3n. So pag ni-reciprocal, magiging less than siya. So bn plus 1 is less than b sub n. So this means na as you increase yung n mo, magdi-decrease itong b sub n. So nagdi-decrease yung series na ito. Furthermore, limit ng b sub n as n approaches infinity is the limit nitong 1 over 3n, which is equal to 0. So, bakit? Yung n is nasa baba. So, kapag infinity yung denominator, automatic 0 na siya. So, yung alternating series test is conclusive kasi equals to 0 yung limit and nag-decrease itong b sub n. So, itong series na ito is convergent. Thus, the series conditionally converges. Okay, so let's now proceed with the third problem. Determine if the series is convergent or divergent. So, summation ng n equals 1 to positive infinity, n plus 9 factorial over 3n plus 12 factorial. So, pause ulit kung gusto nyo i-solve ito. Okay, so let's see the solution. So let's try using the ratio test. Bakit? Kasi we have factorials here. So automatic mag-ratio test tayo. So let a sub n be n plus 9 factorial all over 3n plus 12 factorial. So yung limit, so ratio test, limit ng n as approaches positive infinity ng absolute value ng ratio ni a sub n plus 1 all over a sub n. So pag ginawa mong n plus 1 ito, yung n plus 9 magiging n plus 10, and yung 3n plus 12 magiging 3n plus 12 plus 3, ay 3n plus 3 plus 12, which is 3n plus 15, which is nakikita nyo dito sa presentation na ito. So this is a sub n plus 1 all over itong a sub n natin. So this is equals to limit as n approaches positive infinity. Notice na magmumultiply ng 3n plus 12 factorial over n plus 9 factorial dito sa nasa numerator. So yung magka-cancel ang n plus 9 factorial at saka yung n plus 9 factorial dito. So matitira ay n plus 10. And itong 3n plus 15 factorial at saka 3n plus 12 factorial magka-cancel din. So since mas malaki itong 3n plus 15, yung denominator ang makakakuha ng mga mas malaking values. So this is 3n plus 15, 3n plus 14, and 3n plus 13. Yung in short, yung mga hindi kasali sa 3n plus 12 factorial ang hindi makakancel. So, notice na n plus 10, then 3n plus 15, 3n plus 14, 3n plus 13. So, pag sinubstitute mo basta-basta infinity, magiging infinity over infinity siya. So, we need to do something para ma-reduce ang ganung possibility. So, we multiply 1 over n cubed all over 1 over n cubed dito sa part na to. And since notice na, yung 1 over n cubed can be split into 3 1 over n, which covers yung tatlong mga nandito. So, pag distribute siya, magiging yung limit as n approaches positive infinity ng absolute value nitong 1 over n squared plus 10 over n cubed all over 3 plus 15 over n, 3 plus 14 over n, 3 plus 13 over n, which is equal to, notice na kapag may n or n squared or n cubed sa denominator, magiging 1 over infinity or kung ano man constant over infinity and magiging 0 siya automatic. And hindi gagalaw itong 3. So mangyayari, magiging 0 plus 0 all over 3 plus 0, 3 plus 0, 3 plus 0 na nasa absolute value, which equals 0. And recall na sa ratio test, kapag less than 1 yung limit, ibig sabihin absolutely convergent na yung series. Therefore, dahil dun, yung series ay absolutely convergent by the ratio test. Okay, let's now proceed with problem number 4. Okay, so determine if the series below is convergent or divergent. So summation n equals 1 to positive infinity. Now, negative 1 raised to 3n minus 2 to n squared all over n raised to n. So pause kung gusto niyo muna isolve ito. Okay, so let's see the solution. So notice na yung lahat na ito may exponent na n. So we can use the root test here. So let's try the root test. Let a sub n be equal to yung nasa loob na expression. So limit nitong a sub n, absolute value raised to 1 over n as n approaches positive infinity, is itong limit as n approaches positive infinity ng negative 1 raised to 3n minus 2, 2 raised to n squared all over n raised to n, raised to 1 over n. So notice na magiging 1 lang to. So matitira is, pag distribute itong 1 over n, magiging 2 raised to n ito over n. So we take that limit as n approaches positive infinity. And notice na infinity over infinity yung magkakalaban. So we need to do something. And in this case, we're going to be applying L'Hopital's rule. So magiging derivative nitong 2 raised to n, which is 2 raised to l and 2, all over derivative ng n, which is 1. So we now take the limit as n approaches positive infinity nito. And notice na kapag yung limit ng 2 raised to n as n approaches positive infinity is always infinity. Tapos pag kinaya sa constant, magiging positive infinity siya. So because of this, positive infinity yung limit. Therefore, the series is divergent by the root test. Okay, so that's it for today's video. Thank you for watching.